presentation is about a new revolution in advanced materials with tube-wall single-walled carbon nanotubes by Mr. Ravi Dabral, CEO OCSiAl India. Well, with 13 plus years of experience in the industry, Mr. Dabral started his journey graduating as a chemical engineer from Birla Institute, getting an MBA from the prestigious Indian Institute of Foreign Trade. He was appointed as the youngest CEO at OCSiAl Group Worldwide after completing a successful stint as managing director of OCSiAl India, bringing with him the revolutionary single-walled carbon nanotube technology to the Indian rubber manufacturing industry. I will be requesting Mr. Dabral to kindly join us on stage to make his presentation. Ladies and gentlemen, of course, requesting you all to please put your hands together for him.
Good morning, ladies and gentlemen. As you would have seen in the brochure, and much to your disappointment, particularly gentlemen, I'm not Ekaterina Gorbunova. I'm sorry for that. She got stuck due to some visa issues. But I'd like to make it even better for you. Oxygen, carbon, silicon, aluminum, that's OCSiAl. And our mission is to change the way we use material. Our mission is to change most of the material used by mankind. We are a global company, and we are the biggest nanotechnology company in the world in many ways, not only in the terms that we are global and have most number of scientists and technical people working on carbon nanotubes, but also because of the sheer number of material that we work with. Our core focus, single-walled carbon nanotubes, can change more than 70% of the material known to man, 70% of the world's $3 trillion worldwide market. So what is single-walled carbon nanotube? We all have heard of the fancy name graphene. Single-walled carbon nanotube are more like graphene tubes. One atom thick layer of carbon, you roll it into a tube, 1 or 2 nanometer in diameter and about 1,000,000 times of its length. That is single-walled carbon nanotube, also called as graphene tubes. And they have some of exceptional properties known to man. They are excellent conductor, lighter than copper but more conductive than copper. They are stronger than steel in tensile direction. They have got excellent thermal stability up to 1000 degrees Celsius and have got very high aspect ratio, length to diameter ratio of about 1,000,000 times. It would be interesting to know that carbon nanotubes were discovered way back in 1991 by a Japanese scientist. And for those of us or you who were doing PhDs 10 years back, 12 years back, there was a big hoopla about single-walled carbon nanotubes. They were the graphenes of 13 years back. What happened in those 13 years was the price of carbon nanotube was just too high to be putting into commercial use. A material can be revolutionary, but it won't cause the revolution unless it works at commercial cost. I hope all of you agree with me. Now, all these exceptional properties of single-walled carbon nanotube combined with another fact that they work at extremely low concentration, sometimes literally in ppms, make carbon nanotube a very excellent material to work with. As you can see the comparison here on the slide, comparing with some conventional fillers or conventional additive, the threshold of use of single-walled carbon nanotube is just extremely low. This is an illustration. If you put same amount of microparticle, nanofiber or single-walled carbon nanotube in same volume, the single-walled carbon nanotube would cover much more space. And how they work is they form their own 3D conductive network inside any polymer you disperse it. Now, when I say any polymer, I literally mean any polymer. Thermoset, thermoplastic, elastomers, name anything. This is an SEM image of a single-walled carbon nanotube dispersed inside an epoxy at different magnification. As I go deeper and deeper at 25,000 magnification, these illuminated ones are single-walled carbon nanotube, and that is how they disperse. So if you want to imagine how single-walled carbon nanotubes would work in your particular kind of polymer, just keep this light into your mind. They would disperse and they would form their own reinforcing 3D network. into any polymer you put it in. Right now, we are producing about 90% of the world's production of single wall carbon nanotube, about 10 tons, and at commercially viable rates. By next year, we plan to produce 5 times of this volume, enough to support global production. We are a very responsible and a compliant company, and the only company in single wall carbon nanotube domain to be REACH compliant. Now, producing single wall carbon nanotubes only is not enough. You have to make them work, and you have to make them work in your kind of polymer. You might come up with, as I said, any kind of polymer, any kind of rubber, FKM, NBR, HNBR, silicon, the list is endless. And carbon nanotubes have to work in it. Now, this is only regarding elastomers, but we have to work with paints also. We have to work with transparent electrodes also, thermoplastics, composites, energy sources also. So, we have our own prototyping lab in Siberia, one of the coldest regions of Russia, where we produce and prototype all these master batches or additives, which can be readily used in end polymers like this, power sources, elastomers, paints and coatings, and many other. The whole objective is to give the customers a product that is ready to be used in their formulation without changing their existing setup. This is very important when we want to commercialize this. And one excellent way of doing this, how OCSiAl does it, it's a crown jewel patented technology of tube-wall matrix. It is one and the only concentrate of carbon nanotubes which has got 10% carbon nanotubes inside, which is pre-dispersed and can be used in a radically simple way just by high speed dispersion through any means. Maybe it's a disperser, maybe it's a Banbury, maybe it's a kneader, the technology which you use. You can use tube-wall matrix with the technology which you use. That is the key point. Now, coming on to a topic of more immediate relevance. What comes to your mind when you think of conductive rubbers? What color comes to your mind? There are high chances it's black, right? Well, this is what carbon nanotube can change immediately now. Conductivity doesn't have to be black anymore. And at the same time, putting something inside your polymer to make it conductive doesn't have to make it weak. An example is this colored silicon, conductive colored silicon, where you put very low amount of carbon nanotubes, 0.2 to 0.05% to get entire range of conductivity. This was just not possible before, and definitely not possible at commercially viable prices. Yes, you could have added silver, you could have added copper coated with silver, nickel coated with silver, but that would find very small and niche application, particularly in defense and aerospace industry. But now it's not like that. And what we have seen and observed in Indian market, Indian industries right now not focusing on, not catering on these applications. These applications are clean room applications. These applications are pharma applications. These applications are high-end, very high quality printer roller applications. China is doing very good in them. We are just not focusing on them. But this is possible now at much more commercially viable cost. All this is done by our product tube-wall matrix 601, which can be used for HCR, LSR and RTV silicon to produce a whole range of conductivity and unable to produce colored and conductive compounds. This is a percolation curve which talks about how much of master batch do you have to use to get what level of conductivity. If you look at closely, which I doubt you can right now, if you look at closely, you will be able to find that on very, very low dosages, you will be able to get extremely high conductivities. Then we did an independent study to consider an effect on mechanical properties with reference to a standard compound and a compound with added carbon black. This was done in RTV, and we know by our experience, you would agree with me, anything you put in RTV, some kind of carbon black on an additive, it decreases the mechanical properties immediately. Here, as you can see, with addition of 3% of matrix, which will be equal to 0.3% of carbon nanotube, there was a very small decrease in comparison to carbon and at some places there was also increase in mechanical properties. This can be proven in your lab also. So, you can preserve mechanical properties and also bring in conductivity in RTVs. Again, it is also unprecedented, it was just not possible before. Now, prospective applications are cable accessories, electronics, roller plates, profile, and many. Frankly speaking, you are the better judge of that. We have more than 1,200 projects running worldwide globally in these kind of applications. Now, let me talk about more commoditized application for more commoditized rubber. Our tube ball matrix solution master batch for journal rubbers, which can be made either in low aromatic oil or can be made plasticizer based depending upon your end polymer need and your end formulation need. When dispersed properly into your compound, any kind of rubber, this is what it would look like. This is an SEM shot of styrene butadiene rubber with carbon nanotube dispersed inside. What you see here, something like a snake, that is an independent bundle of single wall carbon nanotube traversing through the polymer, holding the polymer together, reinforcing the polymer at the same time making it conductive. So, these are some of the key properties which addition of carbon nanotube increase in rubber. Tensile strength goes up, shear hardness sometimes goes up, compression set becomes better, cohesive strengths, hysteresis loss are reduced, abrasion loss are reduced. I'll take all of them one by one in different applications. Again, this is an independent validation that was done in German Institute of Technology for rubbers, where we added 0.1 and 0.3% of single wall carbon nanotube into SBR and HNBR based compound. Just note the kind of increase in tensile strength that you can get by 0.3% addition of 0.3% of carbon nanotube. Tensile strength almost doubles in a few compounds. Then again, for hoses and O-rings, after aging properties, elasticity, tensile strength after aging increases in comparison to any normal compound. Similarly, for HNBR based O-ring compounds and gaskets, heat aging properties increase. After rapid gas decompression, property loss decreases, aging temperature also increases. This can be very important factor in critical applications like offshore and mining, where downtime is very expensive. And then there is a possibility of making conductive elastomers also. Conductive FKM, NBR in conjunction with carbon black, without carbon black. You can also use it with carbon black, it gives synergistic effect along with conductive carbon black and normal carbon black also. This is another example, an EPDM compound where you get a stable conductivity plus colored conductive EPDM at industrial prices. I am talking about a very nominal increase in present price compound, colored conductive EPDM compound. I am very sure a very few of us in this room has seen this, these kind of colored conductive EPDM compounds. Colored anti-static applications which can go into fuel hoses, which can go into conveyor belts, shoe soles and many other applications. Again, you know them better than us. My request would be to focus on those applications more. Now, let me talk about something big now, automotive tires, where we are working with Matrix 203, which is our master batch for tire compounds. Surprisingly, Matrix increases most of the desirable properties of tires, which are abrasion resistance, wet grip and hysteresis loss. This is now the middle one, the gray area that you see is categorization and characterization of present properties in comparison of electrical conductivity, energy efficiency, which is kind of a hysteresis loss, wet grip and abrasion resistance of tire. And the blue line that you see is the change in properties, is the increase in properties which happen after addition of carbon nanotubes. It was quite surprising to see. This was done not in a lab, but with a manufacturer at his own facility. Now, with silica, there are some trade-off that you get by replacing carbon and adding silica to tire recipe. The line you see in green is a line of tangent at 0, that is wet grip, and tangent delta is on the x-axis at 60 degrees Celsius. The green line is compounds with silica, and when you add tubol to it, carbon nanotubes to it, it shifts higher. That means better wet grip. I will show you some application cases also. This is one of the key application cases, one of the first one in the world, where a European producer of industrial and off-road tires made his off-roading tire. This is as you can see, earth moving equipment. The idea was they wanted less downtime and more work time for tire, because tires were getting heated and machine has to be stopped, and there the downtime was very expensive. And also they wanted better abrasion resistance, these two things. Both of them were achieved. The tire heating reduced, that means heat dissipation become better, and abrasion resistance also reduced by adding very small quantity of carbon nanotubes. We have ready commercial results with it right now. Again, in motorcycle tire, where more than abrasion, wet grip is important. Particularly idea regarding this application was the motorcycle manufacturer, which is a subsidiary of OCSiAl only, wanted to manufacture a tire which was lighter than original tire, because this is an electric bike application. At the same time, they did not want to compromise on the life of the tire, which translates into abrasion resistance. They did not want to compromise on the wet grip. By adding very small amount of carbon nanotube, the abrasion resistance was increased by 15%, and we could reduce the weight of the whole tire by about 500 grams. The tire was about 2100 kgs, 2100 grams before, it came to 1650 gram after that. At the same time, in tires, it is also important that you have some electrical conductivity, which was obviously achieved. Then for latex, again this would be interesting to share with you that carbon nanotubes are the only additive with which you can achieve present and the most latest European ESD guidelines. It is surprising. Adding carbon nanotubes to the latex compounds make them conductive. At the same time, you can reduce, there is a possibility of reducing the thickness of the gloves also. Reducing the thickness of the gloves does not always mean saving money on the polymer, it also means better comfort in most of the cases. We are working with clean room applications where gloves are conductive, we are working with reinforcing application where the customer wants to make a glove which is more abrasion resistant and cut and puncture resistant. This is the new standard of gloves. When we ask the leading manufacturers across the world, are they able to achieve it? We get only one answer, right now, no. Then anti-static latex coating. This coating can be made on overalls and ESD overall work wears, and can be made as a carpeting also. The good point is carbon nanotubes can be added in PU, NBR or natural rubber, whatever kind of coating that you want to do. Now, ladies and gentlemen, there has been a lot of talk in this very conference about innovation. It seems everybody wants it. The cases I shared with you right now here, most of them are from across the globe. Not many of them are from India. Despite the fact India being one of the top consumers and producers of rubber, as we all know. You are leaders of today sitting in this room, but the future is knocking on our door. Tomorrow would not be the same as today. The winds of revolution, technological revolution is changing things and uprooting whatever is static very, very fast. Nothing is stopping us, nothing is holding us back, I would say. Not the talent, not the resources, not the equipment on manpower. So I would urge you, all of you, to think beyond, be the world leader in technology, usher a new era. You can do many things, but you can do many things. And please remember, innovations always starts with an I. Thank you.
Thank you very much. We have time for questions. Yes, we can take a few. We have a hand raised, please.
Morning. Two things. You yourself said that 91 it started, and 2017 also you are talking about 50 metric tons. So the growth, I think everyone knows. So what is the hindrance to commercialization? That is one question. Second question, you said you have the master batch with aromatic oil for the tire industry. As you know, tire industry using different type of oil, naphthenic oil, TD oil, RE oil. If you mix it, then it will be a problem. So you will have a different type of master batches for, within the tire company, they use 4 different type of oil, even rubber also. You know, SBR 1712 is with aromatic oil, 1720 TD oil, 83 with RE oil. So how you are going to this one? And then you, after you're talking about 50 metric ton for 2006, which is the area you are expecting? Because the price is definitely, though you're talking about you're commercializing, price will be still high, otherwise it would have commercialized very fast. So which is the area where electronic items and all these, I know these are the high cost items, so they will do that. I'm talking about the tire. Which type of tire in that? That is one thing. When you're talking about using of this carbon nanotube, you are replacing the existing fillers, partially replacing these fillers with, am I right?
Yeah.
With that, because you said
possible and not possible. They will
because
depend.
when you talk about the weight has reduced means obviously you have replaced the traditional fillers by this. So these are the few questions.
Sure. 5.
It's a very interesting subject, but for us also new, so I thought that is
Right, right. You have asked 5 questions. I will try to address them as per my capability. The first one I think is the most important one which you asked, which is what are the handles of commercializing it. And if we can commercialize this, all your other 4 questions automatically get answered. Number 1 I would put right now is the will. I literally mean it when I say it. We came to India about 2 years back. And about 2 years back, I can say this as a compatriot Indian to you. About 2 years back, 4 more offices were opened across the globe. The kind of growth of carbon nanotube consumption in countries like, forget about Korea, forget about Europe, forget about America, China, went multiple fold in comparison to India. If we compare, other than the scale doesn't matter in these kind of technology, what had stopped India from using it? Why is India so much lagging behind? It's definitely not the talent. We have got the best talent in the world. We know it. It's definitely not the resources. We have got resources, a lot of resources. It is the will. Because if we start calculation by end of the costing, we would never be able to make something new. Making something new, R&D is a cost center. It's not a profit center initially. So the will, if there is a will. Now the will comes from the end user, manufacturer, the person who is making the compound or person who is making the tire, and the will also comes from the supplier, for example in this case in OCSiAl. What we do is prototype. We are willing to make bespoke and customized master batches also for applications. That answers your third question regarding tires. So we make customized master batches also, but at the same time the cost dynamics of it, how it would go into your compound or a tire compound and how it would change it, has to be worked out like a chef works out a recipe. Let me compare ourselves to somebody who is selling masala or salt to a chef. And the chef is the one who has to bring in new recipes. It is definitely like that, definitely like that. Whatsoever we have done, right now our 10-ton capacity is completely full by Korean, Chinese, American and also Israeli orders. But whatsoever breakthrough has been done, literally all of them has been done by the end customer, not by us. So the will is very important. If the end customer is willing to do it, we are willing to put our skill into it. Regarding oil, I have already told you we can make bespoke master batches, customized master batches for you. Then the prices right now, what we consider commercially viable is when we say that performance and price have come to a point of trade-off, which they have. So that is the reason I'm stressing this point again and again. It's commercially viable. I guess that answers your 5 questions.
Sir, can we take questions now offhand?
1 minute. It's not clear, but I will close here because I know. I have we have handled the products which were high. Normally $3, $4, we were selling about $30 product also. But unless you prove that, I know the chef, final product, if there is a benefit, then cost is not important. But if you ultimately you have to show that even the final product, maybe the performance, maybe the mileage, maybe the fuel. So ultimately people are talking about the money. You have to prove that by using nano, ultimately maybe the full life cycle of the tires, if they are getting benefit, then only people will use it. It is not in India, but everywhere. Other people maybe try. India people before trying, they will see ask for the cost and what the benefit. This is my 40 years experience of the rubber industry. If you want to work it, you have to go with the result on the tire, not on the laboratory scale. Because a lot of presentation comes in the papers from the IITs, but it's nothing commercialized. So if you want to really successful in India, you have to show the result on the tire. Maybe you have to work free with the one tire company and show the result.
I agree to you. I'll just say one thing. Yes, not we. We can't show tire. We don't manufacture tire. Somebody would show. I hope it is somebody in India. Somebody would show. I really hope it's not somebody in Europe and then we copy it. I hope somebody shows it. But we can't manufacture tires.
Thank you very much. Well, that was an interesting presentation. Then we have, may I request Mr. Vishnu Bhimrajka, Director, Pullman India Limited, if you could please join us here on stage to present a memento to our speaker. Ladies and gentlemen, please put your hands together for him. Thank you very much.